In this problem, we're going to be asked to write an exponential function and then identify whether it's a growth or decay, as well as the end behavior and possible asymptotes in the graph. Notice that each one of these is only 0.5. So here's 1, 2, 3, 4, negative 1, negative 2. So I'm going to just identify the problems I do know. If I go to 1, the intersection point is right here, which is at 5. Here's a good intersection point of 2.5, and 1 goes here. Okay, the reason I do that is if I write out a table, I think it'll help you to identify this. Negative 2 is with 10, negative 1 goes with 5, 0 is 2.5, and 1 goes with 1.25. So, remember, think of this right now here as our pattern. How do I go from one number to the next with consecutive x values? I take the second and divide it by the first, and it means I'm multiplying by 0.5, multiplying by 0.5, multiplying by 0.5. That's significant down here. So y equals the initial value, or y-intercept, of 2.5. The common ratio is 0.5, or you could write 1/2 raised to the x. This is an example looking up above of exponential decay. Again, it rises if we're going backwards and looking at things from the right to the left. What is our end behavior? End behavior. As they go to the far left, there's no limit how high it goes. As they go to the far right, it's approaching a y value of 0. Approaching, but never actually touching. Asymptote. Although we don't see any specific line, unless we transition this equation, it's never going to cross the x-axis. Now the x-axis is the same as the equation y equals 0.